Okay, next question. Welcome back. Question number 4. Okay, first of all, look at the question. Okay, remember to copy the data from the verbal description down to the diagram. First of all, equal mass, so you write mm here. And look at here by a light string, okay, that passes through a frictionless pulley. It means that, okay, the tension between these two should be the same, okay. Next, the pulley will accelerate with infinite acceleration. And then look at here, constant velocity, okay. So acceleration is 0, both of them. So in the time plane, right angle, and then each other, and then makes us an angle theta less than 45. So this one less than 45. So the other one must be larger than 45 because add together is 90. So this is larger than 45. So the right hand side is steeper. And so this one frictionless, so this one should fall down. And this one should go up. Okay, that's all we have from the question. Okay, so look at the option. There are 4 options. Okay, first of all, 8. The net force acting on each block is the same. So look at here, A is 0, so net force is 0. This one also, A is 0, net force is 0. So the first one is correct, option A. But look down, maybe the other is the same too. The weight force acting on each block is different. Weight is mg, right? They have the same mass, okay, so they have the same weight force acting on them, so should be the same, so difference. Well, the magnitude of the normal force acting on each block is the same. Normal force, okay, normal force, okay, normal force, okay. So what is the normal force? Decompose mg into 2 components. So this is mg cosine theta, and this one is mg sine theta. Mg cosine phi. This one might be called it phi, okay. So this is mg cosine phi. So the 2 normal reaction force equals mg cosine theta and mg cosine phi respectively, but theta and phi are different, right? So the normal reaction force should be different. So, well, last one, the magnitude of the force exerted by the string on each block is different. No, remember, light string, frictionless pulley, so this part should have the same forces, okay, same tension of the string. They are one string, so same tension, so wrong. So the answer is A. Remember in exam, look at all the 4 options. Don't be too confident. Thank you.